A function. What is a function? So far, we have covered the three following things: for loops, while loops, and if and else statements. A function can contain all of these things. As such, you can look at it in this representation, where a function is almost like a box, and the things inside of that box are any or all of these previously covered topics within programming in Python. In terms of how a function is laid out and defined within Python, it has a representation as such, where define is the act of defining a function or creating it in that matter. Function, on the other hand, acts as the name of the function. Now, this name doesn't have to be function, it can be anything, but whatever value you put there becomes the name. Lastly, you have parameters. This is the values you wish to pass through to the function. Within Python code, a function could look more like this, where x is our parameter, and it could be used in a for loop, a while loop, or even an if and else statement, or even all three at once. As we looked at in the diagram, we want to structure it kind of like the last example in the diagram. So firstly, with this, we are going to define our function. That is done by defining a function, so we're going to do this with the same line that the diagram displayed to us. So we're going to call our function, just like the diagram. And then for a parameter, we are going to give it a variable. This is technically a parameter to the function, but it will be used as the variable within all the looping and iteration and comparisons within the function, within all the code that the function contains. Now, let me note that this is never ever statically bonded to one parameter. For example, we could have the first variable, another one, so on. And then these would possibly be used in all different places within the function. Just keep that in mind. Functions don't have one parameter, they have a wide range of parameters. But to note on the end of that, that is bonded to how many parameters this function needs. For example, a function that is only needing one parameter to use somewhere within its code base, within its code that's contained within the function, will not enjoy you giving it 4 different parameters. When we get to higher up tutorials in Python to do with object-oriented programming and things that Python is really used for today in the likes of Python and other languages like Java, object-oriented programming languages, when you try to give functions too many parameters when working with real code bases, this can really have errors. Okay, so now that we have our function defined, we can put some code inside of it and see how the parameter can be used within this code. So to start, we're going to just make a for loop. So this is going to be indexing through. So we're going to write for index or I, if you're already familiar with using I. Once again, drawing back, this doesn't have to be index or I. It can be literally whatever you want to call it. But index or I or II or J or X, they're just common practice. So most loops you see on Codebases, whether Stack Overflow, GitHub, maybe other YouTubers for that matter, you'll probably see them commonly use an I or a J or an X for iteration, for for loops and things of that nature. I'm going to use index within this tutorial because I know in the previous tutorials I used index as the word for iteration. So for index let's just do a range, and we're going to do a range from 1 to 10, so 1 to 11, because the computer counts 0 as a integer, as its start integer, so 1 to 10 would only get us 1 to 9, if that makes sense. So once we have this, we can put our variable in play. So I'm simply going to make our index equal the variable. So now this is the parameter called variable, and now this index, every time it iterates through the for loop, is now the variable. So now if we do things to this index, it will do things to the parameter for each iteration. So we'll just do some simple number stuff. So we're going to make a new variable called x, and then we are going to subject that to a small equation. So we can do index times 10. Keep it simple, something like that. Index times 10. And then we want to print what x is for every iteration through from 1 to 10. So this is pretty much as basic as a function can get. Real go-to point for what a function is trying to achieve. It's trying to have a lot of high cohesion and a lot of low coupling. Now, in software engineering, these mean practically what they mean in real English terms. Cohesion meaning, in summary, it has one direct function. This function, you really want your functions to do one specific task. You don't want one function that is responsible for a lot of things. So that's why in object-oriented programming, when I expose you to classes within these tutorials, or whether you're exposed to classes elsewhere, whether that's in regular schooling or by yourself learning, these classes have a bunch of functions, and when in classes they're known as methods. And you want each method to be doing one particular task. Where with having high coupling, you would have more or less the complete opposite. You would have a function that is responsible for a lot of things. So that might not necessarily break your code, as in promoting an error, but it is, less efficient in terms of runtime and in terms of just clean coding. Clean coding, I'd say, isn't necessary or compulsory for you to have for your programs to work, but it is a good practice to start early, and then you just get used to clean coding. So I thought I'd just let you know the backstory and the reason why functions are used so heavily, not only within a lot of programming languages, but quite heavily within object-oriented programming languages. Okay, so we are going to run this program and just see what it does, or run this function to be more specific. Now, there's a catch with this. Functions need a bit more to run, so you need to actually call on the function itself. So I'm going to do that right now on screen, and you can copy along, and then we can run this function. So at the moment the function is just standby and there by itself, so it's not actually going to be executed if you were to compile your code. This function needs to be called upon. So how you do that is you write the name of the function, so as this function, and then you put in the variable. Now, this is the cool part about functions. This variable can now be whatever you want. Whatever you want. So, and when you run this function, when it's called, that number or whatever you put in here in the call statement will be the value for variable within the function when it runs. So say we put in 10 and we run that now. You can see we got 10 hundredths every iteration. Now how that happened is we gave the variable as 10. We made the index be 10 every other time. So basically it's just done 10 times 10 and printed out 10 times 10 for 10 iterations. Just for another example, we could put 100 in there as a number. And if we run this, we got 10 thousands. So what the pointing function really is it has parameters, and these parameters are normally variables within the for loops and while loops and code within the function. So then whatever parameters you give the function, they now become those variables. How this is helpful is because when tasks automate and code automates, maybe these parameters will change. So whatever a user puts in, that will be the now given parameter. So you will not want static inputs. So that is how functions are really utilized majorly within programming, I'd say as a whole, but definitely within object-oriented programming. Okay, so moving forward, I'm just going to go on to an example of having two parameters. So, two parameters is quite simple. We're just going to put support for another parameter within the code within the function, and then we basically just call another parameter within the function call. So we'll make a while loop, and this while loop will be while index is less than, actually we'll change this up. So we want the variable to be the index. So we want the index to equal itself times the variable. Now we just won't get static 10s the whole time, we'll get a few different numbers. So after we do that, we're going to remove this print x here, and we are going to want to do the while loop. So before we do the while loop, we'll put a variable 2 here. We're just going to call that variable 2 like that. So now there's two parameters. And we'll do while index is less than, say, it's a good number, maybe 20. Or we'll get to half, so we'll get to 50. While it's less than 50, we want variable 2 to equal index times 10 then we're going to give this while loop an else statement, even though it will just, the while loop will stop even if it's not meeting the while condition, but an else is just also nice to give it, so you can give it a piece of code to do when the while loop stops, instead of just dipping out of the iteration and moving down the code line. So we're going to say variable 2 equals variable 2. So we want it to equal itself. So there's quick ways to do this, but I just want to show you the whole process that's happening. So we've written down an in-depth approach to it. So it's going to do the same indexing and the same iteration as before when we had the one parameter, which was variable, and Although now the index is going to be itself, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times the variable, which at the moment is 100. We're going to make it 10 for this run. And then a while loop where this index that was just calculated for every iteration is subjected to a less than comparison, and that will be less than the value of 50. And if that is true, because while loops run off Boolean, then variable 2, so the second parameter we give it, it's called variable 2, is now equal to the index times 10. But if it's not, if the index calculated was not less than 50, then variable 2 is just itself. Now functions, I want to add that they normally have return statements. The only reason I'm using prints is because return statements don't print to the terminal, if that makes sense. They just return a value. So that's normally perfect to use within real-time, runtime coding within large projects. You know, you don't want to print absolutely every value and absolutely every variable that was calculated to the terminal. But for these tutorials, I definitely do want to do that. So that's why I'm using print. But I'll give you a little example of a return statement as well. So how I can use a return statement to do print for me is I can define a variable being the print string and then return that print string. So to do that, we can just do print line, and then I'm just going to call this print, and then you want to print variable 2. So we're printing this. And then the return statement is just return print line. So now it will return this, which is just printing this. So you'll still get a printed statement out. But yes, functions normally do returns that don't just keep throwing things at the terminal. It gets values, and those values are used within the code elsewhere during runtime, but it's not always just being spit out to the terminal like most things we've covered previously. So I just want to do the same thing with this line, then write print variable 2, and then return that print line. Alright, so now all that's left is to call a function. Okay guys, I want you to run this now and see what happens. There'll be a little slight issue. Okay, so if you ran this how it is now, you should have only got one number in the terminal, and you're thinking, why'd I only get one number? Okay, return statements. That's the thing with them. A return statement basically tells the function to stop, just like how a break statement, or I guess just a break point, would tell a loop to stop. A return statement tells the function return this, and you've got your result, stop. So what it's done is it's got its first result, and it's basically said, there you go, that's what I got, that's it, you know, in opposed to printing. So we change these to just 2 print statements. I know the above one's a print statement as well, but just to save us time, we do this. And now we run it, we get a big old def loop. So as you can see in the terminal to the right, it's gonna go forever. Now that's because of the while loop. So as you know before, Control-C, keyboard, interrupt that. And trust me, there's a lot more to learn on functions, and I'll have future videos regarding functions and a lot of things to do with them. It's definitely not enough time in one 20-ish minute video to cover everything about a function, but I just want to cover the basics. You know, I want to cover how they work. So I hope this gave you an idea of how functions work within Python and in general. other programming languages will have different syntax and some differences here and there, but the main idea of them and what they do is basically the same for most computer languages. So I hope you can at least call yourself a bit more familiar with functions from this video, but of course go and practice them yourself, even beyond just tutorial here or tutorials in general. I'd recommend go and build a little project with functions, use one function to build something cool that you've been thinking of or something like that. So I just want to thank everybody for watching today's video, and I hope you could learn something today.